So hello everyone. So one more question from the PYQ of NAT Mathematics based on linear algebra. Now what it is saying, let F5 denote the field with 5 elements. Then how many matrices with the entries in F5 will have rank as 1? Okay, so the question is asking about the number of matrices whose rank is 1. Okay, now let us rewind the concept of rank. Rank of a matrix is what? The highest order non-vanishing determinant obtained from a given matrix. Non-vanishing determinant obtained from a matrix. In this problem, it is given the matrix is of order 2 by 2. So a 2 by 2 matrix looks like this. If it is having 4 entries, so this is how it looks like. Where what it is given, these ABCD, these entries which are ABCDs comes from F5. F5 is a field. So F5 is a field on the operation plus 5 and cross 5, addition and multiplication modulo 5. So what will be the entries in F5? It will looks like 0, 1, 2, 3, 4. And the operation that is there in this field are these two. Okay, so now this is how the structure of A is there, and we are supposed to find how many matrices exist whose rank is 1. Whose rank is 1. That means satisfying this condition, ABCDs comes from F5 and will have the rank as 1. Will have the rank as 1. Okay, so having the rank of 1 gives you idea about the two things. The first thing is what? The matrix is a non-zero matrix. The matrix is non-zero matrix. It is a non-zero matrix. Why it is non-zero matrix? Because if it is 0, the rank will comes out as 0. Okay. Second point I can say, the determinant of this 2 by 2 matrix is 0. The determinant of this 2 by 2 matrix is 0, which says that the rank can't be 2, and the first condition is saying non-zero matrix, so the rank is at least 1. So hence this condition will satisfy. So we can say that the determinant of this matrix is 0, or which is identical to say, if I am calling this as R1 row, this as R2 row, the second row is dependent on the first row, or we can say that the rows of this matrix are linearly dependent to each other. Linearly dependent to each other means I can say R1 equals to some lambda times R2. R1 equals to some lambda times R2. Okay, so this is how we can understand that what rank 1 means in this problem. Obviously, as a linearly independent concept, we are talking about the non-zero multiplier. So this multiplier should be a non-zero term. Okay, so by keeping these two facts in our mind, we are supposed to find the number of matrices that this type, the number of matrices whose rank is 1 and entries comes from F5. Okay, so I am dividing this calculation into two portions. The in the first portion, I am taking row number 1 as non-zero. That means I am taking R1 as non-zero. And then I will take at R1 as 0. R1 as 0 row. 0 row and non-zero row. Okay. So now let us count the choices. So I will count the choices for both of the cases and then add them to get the number of matrices whose rank is 1. Now let us count the choices for row number 1. So how many choices A is having? So we do have total 5 elements, 1, 2, 3, 4, 5. Elements comes from R5. So first element is having 5 choices. The same for second. So how many choices we do have for R1? Total 25. But in this 25, one one choice which gives you the row as 0, 0 is also included. So in order to get non-zero choices, I should subtract that 1 from here. So I get 24 choices when R1 is non-zero. 24 choices when R1 is non-zero. Now I am supposed to make in both the cases that the rank of the matrix is 1. Okay, so if R1 is 0, how many choices R2 will have? How many choices R2 will have? So as per the definition, what I am saying that R2 should be multiple of R1, that is R2 should be linearly dependent on R1, or I can say R1 can be written as some lambda times R2. Lambda comes from where? Lambda comes from F5. Okay. So now how many such R2 exist? How many such R2 will exist? In that cases, if suppose that I am taking one choice, let your R1 is 2, 3. So for this R1, how many R2 is possible? The R2 can be taken as 0, 0. That means R2 is taken as 0, 0. I am taking R2 as some lambda times R1. So if lambda is 0, so 0, 0 is there. If lambda is 1, it will be 2, 3. Lambda is 2, then it will be 2, that 4, 6. Okay. And in all these cases, rank is 1. Yes, because the second row is dependent on the first row. So in this cases, R2 will have how many choices? 1, 2, 3, 4, 5. The multiple can be taken as 5, 6, 7 also. But in F5, 5 is identical as 0, 6 is identical as 1, 7 is identical as 2. So after 4, the repetition comes out. So the number of choices for R2, how many? This is for R1. For R2, we do have 5 choices. For R2, we do have 5 choices. For R1, 24 choices. So how many total such matrix exist where R1 is non-zero and ABCD comes from F5 and the rank of matrix is 1 will be the number of choices for R1 into the number of choices for R2. So it will make as 4, 5, 20, 120. So case number 1 for this bifurcation gives you total 120 matrices where the matrix is of 2 by 2 and the entries comes out from F5 with the rank comes out as 1. Now what will happen? Is it covering all the cases? The answer is no. We left with one cases, which is what? If you see, we remove -1 from 25 for 0 rows. Now what will happen if your R1 is 0? I am fixing R1 as 0. Now how many choices are there for R2? If R1 is 0, then how many choices R2 will have? How many choices R2 will have? Let us try to see it. This is C and D. Total 5 choices from F5. Total 5 choices F5. So 25, which is 5 cross 5. But in 25, 0, 0 is also there. What will happen if I take C and D 0, 0? In this case, the matrix will not have rank 1. But the question is asking for rank 1. So 25 minus 1. Subtracting that case when CD is 0. So how many cases comes out as 24? So if I am making R1 as non-zero, I am getting 120 options, 120 matrices such that rank is 1. And if I am making R1 as 0 row, in that case I am getting 24 choices where the rank of A comes out as 1. Now the total number of choices? The total number of choices case number 1 or case number 2. That means 144. So in this manner, total 144 matrices are exist or are there such that whose entries comes from F5 and The rank is 1. So the right answer for the situation problem is 144. I hope you understand it.